So one thing that anthropologists have noticed is that really every group and every tribe has its own native language. Even if you speak the same main language as somebody else, you're going to have your own custom jargon and things that you say that are different than everybody else. It's quite likely you've already experienced that with server or network or storage, terms and jargon and words and acronyms that just don't make sense unless you've had a chance to work in that particular field. So in this nugget, we're going to learn some of the language of NSX and get our feet firmly planted in the terminology that we use there. Just to make our lives a little bit easier, we'll go ahead and use this diagram that presents the different components relative to the planes of operation in which they occur. So first, let's talk at the data plane about the idea of distributed services. Distributed services mean that the service that normally would be provided by a physical device is going to actually be distributed and run in the kernel of our ESXi hosts. So ESXi, for example, has virtual distributed switches. Those virtual distributed switches can then be made available to function like a common switch across multiple ESXi hosts where it's actually connected to each other, and that's going to be what's known as a logical switch. And again, that switch is not a VM, it's not a physical device, it is a service being provided by ESXi. Likewise, we can actually have a distributed logical router. And this one will sometimes actually get the acronym DLR for Distributed Logical Router, which means receiving an IP packet and knowing how to forward that packet according to a routing table is being done in the ESXi kernel. That's not a VM, that is a routing service in all of the ESXi hosts so that any VM that needs to route out of a switch and into a different network can do so without ever having to touch a physical device. And wouldn't you know it, there's also a distributed logical firewall. It's another one of these same services. Guess where it runs? That's right. That's a firewall service that's going to block packets that don't meet the firewall rules right there at the ESXi host level. Now here at the data plane, we've got these great distributed services running in the ESXi hypervisor, but then we also have NSX edge services. And edge services are actually talking about a VM. And because it's a specific VM that is running a routing service, that particular VM functions as a great transition point between the physical and the virtual. It's going to be what actually hands off to the physical network many of our packets that we're trying to forward. Also, it's not just any lane brain router. This router can also do load balancing, it can perform firewalling, and it can function as an edge point for VPN services. So most of the time when we think about rolling out our software-defined networking with NSX, we're going to be imagining, creating, and configuring logical switches, logical routers, distributed firewalls, and edge services. But those services, because we work with software-defined networking, have been decoupled from the management and data plane. So we got to know what the management and data plane tools are that are going to coordinate with that. So the top level component to be aware of is the NSX Manager. The NSX Manager is actually a VM, it's a virtual appliance technically, that we will download and install into our vSphere environment, and we're going to connect it to our vCenter server. As an administrator, there's almost no administration done directly with the NSX Manager. Instead, all of the cool operations like creating and configuring our switches and routers and firewalls and edge services is going to be done through the vCenter server through an extension provided by the NSX Manager. Now at the control plane, we've got two core elements. We've got the NSX Logical Router Control VM, which is the control element for our distributed logical routers, our DLRs. So this is the central focal point for communications with BGP or OSPF, where we need to have a single point of contact rather than trying to reach each and every ESXi host individually when they're all functioning like one logical router that's distributed across all those hosts. So this VM is literally a VM installed in vSphere that's going to give us that function. Likewise, we're going to have the NSX control cluster, which is responsible for all of the control plane operations for switches and also provides some other elements of control operations for our logical routers. It is a cluster of 3 VMs. It's not 1, it's not 2, it's not 4 or 12, it's 3 VMs installed into a cluster on vSphere. Now there's a couple of agents mentioned over here, and I want to talk about what those do as well. The user world agent or netCPA is actually installed on the ESXi host, and that agent is designed to be able to communicate with the message bus agent in order to be able to receive instructions from the NSX Manager. So for example, if we log in to the vCenter server, and in that server we configure a new policy for a distributed router, that policy change is actually occurring in the NSX manager. The message bus agent will then establish an SSL connection to the netcpa user world agent, which is running on that ESXi host, which will then reconfigure the settings on the DLR that is running in that kernel. Finally, there's one last element that I wanted to mention, and that's called NSX Service Composer. The NSX Service Composer is all about being able to more efficiently push out our security and networking services into our infrastructure. And it does so in a large part by the idea of creating groups, which then allow us to push policies to the group of VMs based upon a common property that they have, rather than having to push out individual instructions to each individual VM. You got to know the slang if you want to be one of the cool kids. I hope this has been informative for you, and I'd like to thank you for viewing.